Hi, welcome to my channel. Today I'm going to talk a little bit about COMSOL Multiphysics, and we are going to simulate a very common problem that we see when electromagnetic waves falls on a medium, and how does it interact with it. So we are going to see that. So today I have made a video for that, and I'm going to explain that. So here I have opened the COMSOL Multiphysics COMSOL Multiphysics application, and in here you can see there is a model wizard and a blank model. So first we'll go and click the model wizard, then we'll click on 2D because we are working with the 2D space, and next we have to select the optics. Because we have taken electromagnetic waves, we will select wave optics. So in here we select wave optics, and then we go to electromagnetic waves frequency domain. So we want to work in this physics. Next we click study, and from here we choose the wavelength domain, and then we click done. Wavelength domain, because we will be working from within a given wavelength range of 400 to 1500, or from 100 nanometer to 400 nanometer. So here we first change the length scale. Length scale will be changed to first into to micrometers. Because we are working with micrometer scale geometry. Next we'll go to the global definitions. We'll click on global definitions, and we will write down few of the parameters. So the parameters are an important part of this geometry, because each and every time you do not have to input anything, any new value. You can just change the parameters and put width as a variable. So we are using width, the name width, as a variable here. So these are just the initiation of the variables first. So here we take width of 0.5 micrometers and height of 0.5 micrometers as well, and the refractive index of the material, the n naught, as 1.5, just to differentiate between air and any medium. Just that's why I have taken 1.5, which is also refractive index of a glass. So now next go and click, let's click on geometry and then select rectangular from that. So we go and select rectangle or rectangular from that, and we put the width and the height that we have already mentioned, and we label it air, just we shouldn't be confused. And also we have reduced the height by 2. We can keep the height as same like that, and we have and in this we'll just first build the object, and also the base is kept at center at x equals to 0, y equals to 0. So the next part will be to duplicate this air, or we'll get another air 1. So we'll name this as a medium. So what we are doing, we are trying to show the air and the medium's interaction. Here we are going to build that, and here just we'll put minus height by 2, because we are putting air on top and the medium at the bottom. Here in the graphics you can see that it is done like that. Okay, so the next part will come to the material. Assigning the material is an important part here, because we have to give them their refractive index. For that we will go to the material, adding of materials from materials bar, and then we select air. As you can see that air has been selected for both of these materials, so we have to deselect one and select just the top rectangular geometry. And the bottom, for the bottom rectangular geometry, we have to add another blank material. In this blank material, first we have to go and select the properties. So for selecting the properties, let's go to electromagnetic models, then to refractive index, then refractive index, imaginary part, and real part. You can consider any one and just add the plus sign. You can see the plus sign here, and both of them are added. We have already mentioned the refractive index, so we will just put n naught here. That's it. And now the next part is to select the material. So the medium, we have selected the top medium as air. So we select the bottom medium now, which is the medium 2. Then, so our material is fine right now. The top one is air, the bottom one is some medium. Next, we go to our study or our physics, that is the electromagnetic waves frequency domain. Here we see that there is some wave equation, perfectly electric conductor, some initial values that have been given. So we first select the initial port. The port is something that from where you will actually launch the light, launch the electromagnetic wave. So we select this one as our port or our initial port. We name it as our input port. Yes, so we are naming it as input port. Uh, input port. Next, we will go to type of port. We have already selected. So next, we will go to the type of port. So type of port will be periodic. We want to have a periodic, a periodic light at this port. The wave excitation has to be switched on because obviously we are launching the light from here, and we'll have a TM wave falling on this at a 90-degree angle from means falling normally on the surface. So that will be a TM wave, and as you can see that the next part will be to get the output port. So we will again select electromagnetic waves frequency domain and select output port, and from that we will see that we have to do the same thing. So the input port is 5, the output port is 2, and we are talking about the 2 and 5 as the boundaries. So the type of port again periodic, but in this case the wave excitation has to be switched off, and the E in the x-axis will be 1 again. Now when we see the sides of this both of this media, the boundaries must not contribute anything to the interaction that is happening between the air and the media. So we are putting a scattering boundary condition. So we can select that from the electromagnetic waves frequency domain again, and so we place them all at the side. So our entire geometry is now prepared. So we next go to meshing. Meshing is an important part. We'll come to that later when we are going deep into some problems in electromagnetic theory or photonics. We'll go into that. So everything else is done. Its materials are assigned. Electromagnetic studies is also has also been assigned. The parameters are assigned. Next we go to meshing. The scattering boundary conditions are assigned. Next we go to meshing. So so we'll first select finer machine and build all. So you see that it is properly meshed, and meshing is actually dividing each part into very small portions. So we will go with a wavelength range of wavelengths that are falling on the top of this on the boundary of or on the boundary of air and the media. So we'll select the, I think it's not visible here, but you can go to the range part as I have clicked at the side of the wavelengths, and just write where the start and the stop of the wavelength and the differences between it. Here I will start with 0.1 micrometer, and I will go to 1.55 micrometer, and with a step size of just 0.01 micrometer, and then I'll go with compute. So it will take some time for computation, so I'll just forward that. and that's it. So our computation is done. As you can see, there are 141 frames that have been developed. So we'll go to the results, go to electric field EWFT, and then go to the surface and click on the surface. So here actually I can go to directly to animation and see how it is being animated. So here is an important result that you have to see. If I put it in repeat, and if I display each frame for around 0.5, around 0.5, yes, and if I put it in repeat, so you will see each frames for a longer period of time, and you can understand that what happens. So initially the waves had a higher smaller wavelength that was falling, but when it's interacting with the other media, it's having higher wavelength. So the wavelength changes across the two media, and it depends upon the refractive index of the media n. So that's what we were planning to do here. It's a very simple simulations that I have done using COMSOL, and also you can see that, yes, so this frame actually talks about that the initial frame the initial wavelengths are much higher compared to the output wavelengths, which are much smaller. So the frequency increases in the medium too. So next we click on surface, and then we there's some glitch here probably, so let me delete it. And okay, so again I click on surface, and yes, so no, the deformation, this will not work. So again I have to go with height expression. Yes, yeah, so just we have to click on surface, right click on surface, and then you'll see height expression. As you can see the height expression, and then we just go and click on animation and just the play button. They will again do a frame by frame rendering, and here you can see a much better view of what is happening to the waves, the three-dimensional waves. How are they actually getting projected on the two medias. So that's it. Thank you. So any comments? I would love any comments, and uh, you can show your appreciation by your likes. So thank you for watching this video.